Okay, good evening, everybody. So today we're going to be talking about factoring special types of quadratics, and we have two that we're going to be working on. The first one is going to be a perfect squares quadratic, and you'll see that in just a second. And then the other one is called difference of squares. And so these are kind of long notes. I have 6 slides to go through. They're not particularly long in the process. It's a lot about recognition, so I'm going to try and go kind of quickly. If you need to pause or rewind, today would be a great day to do that because there's a lot about recognition here, so you have to take some time to think and understand what I'm talking about here. Also, I'm going to try and use a little bit different colors today, so this is going to be my blue color. And I'll erase this in just a second, just so you know. It's a little bit different color blue than before. This is my red color, and this is my green. So hopefully you guys will be able to tell the difference between those a little bit easier. There was some difficulty earlier. Okay. So here we go. So we're going to talk about finding perfect square trinomials, and what I mean by that is we're going to be factoring them, and we couldn't factor it the old way. This always works, and I know that some of you are going, oh sweet, if it works, why don't I just do it that way then? But of course, we want to do things the most efficient way as we can. So we can do a diamond problem. So this is going to be 9x squared, and then 6x on the bottom, and 3x and 3x, and then we can do a generic rectangle, and we get x squared and 9 and 3x and 3x and x times x plus 3 plus 3. So then what we end up with is x plus 3 times x plus 3, or x plus 3 squared, and that's why we call it perfect squares. So this is fine. You know, there's nothing wrong with this. You will factor it, no problem. But I'm going to show you another way that I want you guys to try and start recognizing and using. Actually, you're going to be doing this first. The very first thing you're going to do is going to be checking this technique. So you guys will keep writing down below your page. I'm going to go ahead and erase so that I can use the same problem and have a little bit more space here. So the first thing you do when you see a trinomial is I want you to check some things. You can do this mentally or actually physically write it down and check it. But I want you to check to see if something will work. If this thing works, then that's exactly what I want you to do. I want you to use this shortcut. All right, so the first thing I want you to do is this. I want you to take the square root of the first term. Okay, so take the square root of the first term. And the square root of the first term is x. Then take square root of the last term and make sure you include the 9, or the positive sign. Square root of that is 3. And then multiply this by 2. So if you multiply 3x times 2, that gives you 6x. That is the same as your b term. That means this is a perfect square trinomial. So if that's a perfect square trinomial, then we already know what the factors are going to be. The factors are going to be the square root of the first, which is x, plus, because this symbol right here is positive, so therefore it's that symbol, and the square root of the last term, which is 3, and then as we saw a second ago, that's squared. So x plus 3 squared. I know that's kind of convoluted and mixed around there. We'll take a look at another one, and I'll do a little more slickly. All right, so here we go. We got another one. First thing I want to do is I want to take the square root of the first term, which is x, square root of the last term, which is 5, and then I double this. So if I double that, that gives me 10x, which is what I wanted. Therefore, the factors of this are going to be x squared plus 5x. No, it's not. What am I doing? Pay attention. It's going to be x squared plus 5, and it's not x squared. What am I doing? See, I'm thinking about other things. Sorry about that. It's going to be x plus 5 squared. So x plus 5 squared is equal to that trinomial. Okay? Now you're thinking, you might be saying to yourself, well, what if it was x squared minus 10x plus 25? Well, in that case, I take the square root of this one and the square root of that one. And that's x and 5, and I double that and I get 10, so that still works. So then I put a minus sign in the middle, and that minus sign is that minus sign, So it's x minus 5 squared. So this symbol here has to be positive, and this symbol has to be positive. This one here can be positive or negative. Whatever sign that is, that is. So whatever sign that is, that is. Okay, let's take a look at the next one. Okay, so the very first thing we're going to do here is we're going to take the square root of the first sign. So the square root of the first sign is 2x. Square root of the last sign is 3. And then that gives me a total of 6x. And if I double 6x, that gives me 12. So that equals 12x if I double it. And so that means it's a perfect square trinomial. So then my factors are going to be 2x, and then because this is positive, plus, and then 3. That comes from there, and then squared. Okay? So let's take a look at the next one. One more here. If I had this, okay, so if I got this one, and I'm sorry, I don't know why I did it in green, but at this point I'm not going to go back and switch it. So you're going, okay, well, this is a perfect square, so that works, but that's not. So then, since that's not a perfect square, this is not a perfect square trinomial, which means you have to do generic rectangles and diamond problems. If it's not a perfect square trinomial, that means you've got to do generic rectangles and diamond problems. Make sure you write that down. If this does not work, or this does not work, then you must do generic rectangles and diamond problems. Okay, take a look at the next one here. All right, now we're talking about difference of squares. And difference of squares look very different. The first thing you might notice is that this is a binomial. There's only 2 terms. So every time you have a binomial, you want to hope that it's going to be a difference of squares. Okay, so this is a binomial. That's the first thing you want to notice. The second thing you notice is that the binomial is negative. That has to be the case. Either the x squared term needs to be negative or the constant needs to be negative. But one of them has to be negative, and they both can't be negative, but one of them has to be negative. If that's the case, and then you can check and see, is this a perfect square and is that a perfect square? If both a and c are perfect squares, then you can take the square root of x squared is x, the square root of 16 is 4, and then you do that again, x and 4, and the only thing you have to do is one of these is positive and the other one is negative. So the factors of x squared minus 16 are x plus 4 and x minus 4. Okay, so let's take a look at the next example down here. The first thing I notice is that it is a binomial. I like that. And then the next thing I notice is that one of them is negative. No worries. If that's the case, perfect. Then I'm going to say the square root of x squared is x, and the square root of 25 is 5, and I have 1 plus and 1 minus. So there we go. X squared minus 25 is equal to x plus 5, x minus 5. Once again, we have this. I'm going to go ahead and change this problem a little bit to show you that we have something else. What if it looked like this? Okay, so here I still have a binomial, and one of them is positive and one of them is negative. So that's good. That's what I wanted. So I can take the square root of this. So I have 3x, and then the square root of that, which is 8. So I'm going to have negative 3x plus 8 times positive 3x plus 8. So you notice on this one, I changed the negative sign here and the positive sign there. So whichever one is negative, and I need one of these to be negative and one to be positive so that I get a negative 9 there. All right, so that's that one. And then on this one here, I'm going to change this answer too real quick. Okay, so there we go. And the first thing that I notice is that I have a binomial, so that's good. and don't have anything that's negative. That's bad. So I cannot factor. So I have to do this. I can't use a shortcut. And we'll learn something else about this process as well. But that's it. So the very first thing you're looking for is one of them to be negative, one to be positive. And if they are, then you take the square root of the first, square root of the second. If they're perfect squares, then you can do the shortcut. All right. And, oh, shoot, I kind of jumped the gun. I forgot I did this problem. So there you go, same thing. So I have a binomial, which is good, but there's no negatives, so they're positive, so therefore not possible. And there we go. That's the notes for today. We'll talk more about these tomorrow. Again, this will really help you factor much more quickly if you can find these perfect square trinomials or difference of squares trinomials. So difference of squares trinomials and perfect square trinomials. All right. See you guys tomorrow.